Thanks for joining us this afternoon and welcome to Shortport Challenge Roadshow 2022. So during the roadshow, we have the opportunity to speak to our corporates and understand a little bit more about these innovation opportunities. So my name is Jolene, I'm from the PN21 program team and I'll be moderating this session. So in case you're not familiar with SPC, it's a flagship event of PN21, which stands for Port Innovation Ecosystem Reimagine at Block 21, and it's a program which is co-founded by MPA as well as NUS Enterprise. So this year, we have 15 innovation opportunities which are championed by 22 maritime corporates as well as organizations. So during this roadshow, we actually encourage you to ask your questions. The corporates are here to answer them, or you can put your questions in the Q&A function throughout this session. So to quickly kick off this session, we'd like to show a quick overview of video. Yeah, could we have the video on screen, please?
A vessel is subjected to three environmental forces: wind, currents, and waves. The onboard dynamic positioning system, also known as the DPS, tries to counteract these forces in order to maintain the vessel's position and heading by using its propellers and thrusters. One of the limitations of the DPS is the lack of data on currents and waves. For this reason, it maintains a station area known as the watch-keeping circle. This is a circumference within which the vessel floats away from its desired position as a result of these unknown forces. Moving the vessel back means increasing thrust and propulsion and burning more fuel. If we could reduce the watch-keeping circle by adding wave as a known factor, it could improve operational efficiency and safety. Safety is especially important during operations when we transfer people to and from the ship while at sea. Additionally, it will reduce our environmental impact. While there are standalone solutions for wave prediction, measuring waves is complex. They can come from any direction, are continually changing, and their force can be reduced or amplified by other waves. Bernhard Schulte Offshore and Innoport are looking for a solution that will provide the vessel's DPS with more accurate intelligence and empower it to make better predictions and decisions to improve performance, operational efficiency, as well as crew safety.
So I think we can start off with the innovation opportunity, which is how might we empower vessels with DPS to make better weather-based decisions to improve performance efficiency and crew safety. So this afternoon, we have Moritz and Andres from Bernhard Schulte Offshore and Haymon and Jessica from Innoport. So maybe I'll hand over the time for you to quickly introduce yourself, a little bit about BSO as well as Innoport, and you could quickly go into the context afterwards. Haymon?
Thank you very much, Jolene, and good morning, good afternoon, everyone. My name is Haymon. I'm part of the Innoport team, and so is Jessica here with me on the call. Innoport is the corporate venture capital arm of the Schulte Group. And the Schulte Group is a family-owned shipping business based in Germany with core businesses in ship owning and ship management, owning a fleet of about 100 vessels and managing about 600 vessels. Apart from the two core businesses, we have built up over the last 20, 30 years a large portfolio of service companies, a lot of those servicing the ship management side that includes a port agency and launchboard services, ship chanting, etc. As well, the Schulte Group has built up various business units, such as the offshore side, to build up additional verticals. And Moritz will give an introduction later on that as well. Innoport, as the corporate venture capital arm, invests in early stage startups in the maritime space. And we like to do strategic investments where one of our business units within the group can benefit from the technology and where at the same time we can give something back to the startups by advising them with our expertise, with doing pilot projects with them, becoming a customer, and therefore really trying to enhance the innovation within our industry. So we really like to support them wherever we can. And once we have vetted those solutions, we are as well happy to invest them with equity via Innoport. So now I'll hand it over to Moritz and Andres to talk a bit about BS Offshore and the challenge statement in particular. Thank you.
Yeah, thank you very much, Haymon. Yeah, Andres and myself are working for BS Offshore, the ship-owning arm, offshore-owning arm of the Schulte Group. And maybe, even though we had a brilliant video from Jessica as an introduction, maybe let me share a few slides to give you more of an idea why the problem of keeping a watch-keeping circle is so important, especially for the crew safety. Let's see if this is going to work. 1 second. Oh, there we go. So everyone can see us. So the question is why the BP positioning keeping is so important, especially in our service operation vessels. SOV stands for service operation vessel. One of them you see on here. It's one of these beautiful blue vessels that are operating in the North Sea in the wind parks, and the core work for them is delivering people to the wind turbines. Haymon already gave a background on the Schulte Group. Here, maybe a little bit visual support of that. We really act globally. Although Anders and I are based in Hamburg, the Schulte Group is acting globally, so we're even based in West Africa, South America, and very strong on the Asian side. Also starting businesses in the Arabian Gulf and everywhere. And those areas are different projects on offshore where this problem is really quite crucial for our business. In total, we manage a fleet of a bit more than 600 vessels. Most of them are not offshore vessels, but quite a few are. We're providing crew to the vessels. We own offshore vessels, and we're working also on conversion of offshore vessels. So let me maybe give you an idea. On the wind side, Bernhard Schulte Offshore, or BS Offshore, is part of Windea. Windea is a one-stop solution for the German wind parks, where we offer services with our SOVs, which you can see on the top left, but also other services needed in the wind park. Crew transfer vessels, those are the smaller, faster ones, helicopter services, blade repair, so one-stop solution. And all of these could benefit from a solution which we put on the challenge. So what are we doing with the SOVs? We currently have 3 ones. Our newest baby, the Windea Jules Verne. She's a very fancy, beautiful vessel, and the little bit older ones, Windea La Cour and Windea Leibniz. They have technicians on board to service the wind turbines. So what do? Is they stay in the wind park. At night, they're mostly drifting around, and then in the morning, all the different technicians teams get ready, have breakfast, get all the tools, while the ship is approaching the wind turbine. And as you can see in the middle and the right picture, the vessel is really close to those wind turbines, putting out this gangway. And then people and whatever tools they need are getting transferred to the wind turbine or from the wind turbine to the vessel. And since we're really close there, the station keeping capability of the vessel is extremely important. First of all, we of course do not want to hit any infrastructures, but second of all, we're transporting people over this gangway. And if we don't keep the position properly, there is always the terrible risk of this gangway detaching, or we have to stop operations, of course, before this happens. Yeah, that's not good. If we have now a system which could help us with these unknown factors of the current and the waves, our performance of being attached to this wind turbine and more weather windows are much better. You could be more efficient with the use of energy you have on the engines and propellers and keeping the station. And of course, if you're more efficient, it's also good for your carbon footprint. So yeah, this is what we essentially do. Just some numbers. On the bigger vessel, we in total are about 120 people. On the smaller ones, we are 60, but also extendable to just over 100 people. So quite a few people are on board. Just to give an example of other vessels which have walk to work, that's what we call it with the gangway, which also would benefit here, is an older vessel, the Ocean Sapphire. She's a converted vessel, not purpose-built like the blue ones. Essentially an oil and gas ship where we put the gangway. You can see the gangway there just next to the crane. Or even larger ones, accommodation vessels or flotels. These two green vessels operate in the Gulf of Mexico, and they have more than 700 people on board. And essentially for all the oil platforms in that area are the hotel for those guys. But also these vessels do helicopter refueling. You can see there's a helipad, and those oil fields are quite far offshore. And the helicopters benefit hugely when they can refuel there. Also there, if you are good at station keeping, it makes the whole operation much safer. What else we have? Yeah, this is just a quick explanation why our blue vessels, our SOVs, are so efficient. So you basically have two different kinds of doing it. You can have these CTVs, these smaller, very fast vessels, doing all the work, but the problem is they lose a lot of efficiency time when traveling from shore to the wind turbines. They can't work in all weathers. They're quite limited in wave heights, and wind and current and so forth. And this is all resulting in much less effective work time. So if you have technicians on board, they need to go to the coast lines, aboard the vessel, go out with the CTV, and this is all lost work time. Whereas with the SOVs, we are on the wind farm, and we basically can use all the time of the technicians on board when they start working in the morning, after having the breakfast and preparing and getting over the wind turbines. So it's much, much more efficient, and also just using much more sense of the time we have of the technicians, of the resources we have for them. Then what you also do is, of course, there's not only one turbine in the park, there are multiple turbines in the park. So we approach one turbine, drop the technicians off, and half an hour later with the next turbine, and so forth, until all of these technician teams are dropped off at the wind turbines. They do the work. During the day, the vessel can do other work in the parks, but it's also the DPS system is needed, and then in the afternoon and the evening, the technicians are getting picked up again from the wind turbines. And all these work times from the different teams, you can stagger, meaning they don't start at the same time of the day. And this then also grants you more efficient use of the work time. All of it comes down to it also on the weather limits. A CTV, as I mentioned earlier, has quite reduced capabilities and sense of wave heights where they actually can go to the turbine, even though it says 1.5 meter significant wave height here. We shouldn't forget that this vessel doesn't connect with the gangway, which compensates the motion. They essentially push with the bow against a ladder and then move up and down on the ladder. So the transfer is fairly dangerous, even within those weather limits. Whereas with our vessel, we make the transfer very, very safe. We want to make it even more safe. If you take all of this together, the weather limits, the staggered approaches, the efficient use of time, not having travel time into the wind park and out of the wind park, overall we have a much more effective work time with our vessels. And this is why looking ahead, this we see as the preferred solution for all upcoming wind parks. Especially in Asia, a lot of projects are coming. Also, Europe is accelerating some of the plans, and North America anyhow. Especially President Biden has introduced quite a lot of legislation in the past week or past 2 weeks, which will allow accelerated growth of wind parks, and where this is also urgently needed. To give an idea of what our vessels are doing, this is now, for people not familiar, the German Bait. It's the southeastern part of the North Sea. You can see it's just a northern tip of Germany going into Denmark. And there we have a few different wind farms. And what you see here, the blue lines, is the track of the vessels, how they're operated. So you can see in 2017, we only started servicing 2 wind parks. And the efficiency of our operation was much higher than anticipated by the wind park, or rather by the wind turbine maker. So the vessel actually started then doing more work in other wind parks, harnessing all the efficiencies you have on the workflow on board and the efficiencies of the vessel design itself. So you can see they're really, really busy going all across the different wind parks, having very few port calls and going back out again. So the time of the vessel is really, really used well. Instead of having one of our blue purpose-built vessels, you theoretically could also convert vessels, but they have a lot of downsides. As a summary, the weather window, so the environmental conditions in which they can safely operate, are by far not as good as what we can offer. The facilities for the technicians on board are not as optimal, and so forth and so forth. So our solution on the right, having a purpose-built vessel, which is purpose-built for the station capability, is really the most efficient solution for all of them. It's for the technicians, that they have the best tools to work, they're most safe, it's their best looked after for. It's the best solution for the wind turbine builders, because they can get access to the wind turbines for repair and maintenance for the biggest part of the year, and also for the wind park owner, because if you have access to the wind turbines most part of the year, you can have much more uptime of the turbines, so the turbines turn much longer through the year, producing more electricity, making more money for the wind park owner, but also providing much more energy in the end for everyone benefiting. So yeah, this is our quick introduction on why the position keeping capability is so important for us.
Thank you for giving a very well-rounded introduction. The photos really help to illustrate the point. Because I also understand that the DPS only currently measures wind, and BSO and Innoport are looking for something that also can measure the wave. So will it be possible to share with our startups here how the DPS currently works? Because some of them might not be from the maritime space yet, so it'd be good to give them a bit more context. Haymon?
Sorry, it was a bit difficult to understand you. Did you ask for some more information on how the DPS works?
How the DPS works.
Andres, do you want to say something?
Yes, so then the dynamic positioning system, what tries to do is to keep the vessel in a predefined or in a setup location. So then what does it uses? It uses the different propellers available in the vessel, and uses different measuring devices to check if the vessel is in the predefined or in the set position. So the thrusters are pushing the vessel, moving the vessel around, and the measuring devices are telling the computer that is managing the propellers how much needs to push on each direction in order to be able to be placed on the spot, on the set position. So this computer that is managing the thrusters and as well is taking information from the measuring devices, one of those measuring devices is wind. It's a wind measurement, wind measurement system. So this wind measurement system is taken by the computer, by the dynamic positioning computer, and is creating a model of how much force is exerting that wind to the vessel. And that is one accurate value of the force that the vessel is having, but still have two more forces that are unknown. One of those is the current, but the current is not changing too much, so it's always fixed. It's coming always from the same direction, and the changes, because they are changes, are very slow. And the third one are the waves. Waves are very difficult to measure, to predict, and to know which wave of those that you are seeing actually is going to hit the vessel and is going to create a force on the vessel, together with the wind and together with the current. So the dynamic positioning system only knows the wind and doesn't know the waves, doesn't know the current. Due to that, the vessel is not able to keep an exact position so that it drifts around the desired position. This is called the watch keeping cycle. So for our operation, this gangway that Moritz was showing, that is connecting the vessel with the wind turbine, needs to compensate not only the movement of the vessel, but as well the drift that the vessel is doing around this watch keeping cycle. So the more the vessel drifts from the desired position, the more the gangway will have to compensate for those movements, leaving less compensation available for the actual wave compensation. So the bigger the watch cycle is, the less efficient the SOV is, because not all the gangway can be for compensating the movements of the waves. So that's why it's very important for us, because if we have a small radius and this watch keeping circle, then we can offer to our customers more days of operation. And if we can offer to our customers more days of operation, of course, the revenue is different, the business case looks different, and we are all more happy. So then that's a bit that's a bit the dynamic positioning system. What tries to keep the vessel fixed, and for that is using the thrusters, is using measuring devices to know how far is from the setup position, and is using sensors. But these sensors are only the wind. Current and waves are not known. Therefore, this is the topic of the watch keeping cycle. The vessel is always trying to stay in position, but doesn't know everything, doesn't know all the picture. And that's a challenge.
Yeah, it is. Thanks for sharing. We have a question in the Q&A box. The question is, what are some environmental factors that may affect the measurement of current, wind, and a potential wave sensor?
You have the question, what are some environmental factors that may affect the measurement of the current? Environmental factors, okay, it would be, we are measuring waves. That, I mean, would be ideal to be able to measure waves, but measure waves is extremely difficult, because because which wave are you measuring? Of course, the waves are coming in a certain direction to the vessel, but during the period on which you are spotting the wave, and these waves are developing into you, the wave that is going to hit you is completely different than the wave you have been spotting. So it's a continuous, it is a continuous flow, let's say, of movement that is coming into you. So it is extremely difficult to assess or to be able to forecast based on 3 seconds, 4 seconds, 6 seconds with accuracy. What is the amount of energy you will have to counteract? And that is a bit the challenge, and that is connected with the second question.
Yeah.
Yes, this would have to be integrated into the DP system, because the DP system, as we call it, is a computer, no? And this computer will have to have as an input the type of wave that most likely, because this will be everything probability based. So we will the wave measuring device, let's say, will assess the probability that a type of wave with an amount of energy will hit the vessel, and the DPS will try to correct or to correct or to, let's say, I forgot the name in the control devices. It's not a feedback. It is we need to try to be on top of that energy that is going to hit the vessel. So yes, we'll have to be integrated, same as the wind sensor is integrated with the DPS.
Okay, thanks for sharing. For startups who are here with us today, I encourage you to put your questions into the Q&A function. Yeah, so for startups here today, I think it would be good for them to understand also what kind of support they could get from Innoport as well as BSO. Haymon, would you like to elaborate on this?
Sure, but maybe before I elaborate on that, to maybe add on what Andres said, I think the keeping circle or the position more accurately really enhances also the safety. I mean, the days of operation goes up, but also, I mean, the safety aspect is one. And if we can more accurately predict the oncoming waves, we can also manage the energy much better. So the efficiency of the operation of the DP vessel also increases significantly if we can predict those forces apart from wind on top of as well. In terms of sort of what we can do to support startups in this. So of course, we have a lot of expertise on BSO side in this space. So I think the first support that we can give is really the expertise that we can have discussions about what is actually required, how it can be integrated into the DP system if any startup comes up with a solution to measure the potential energy that the wave can actually force onto the vessel. We can support in maybe helping to connect to the right providers for DP systems. We can offer test beds. I mean, we have the vessels with different types of vessels. We have different DP systems where we can certainly see how we can test bed this. And from Innoport side, there are different areas where we can create connections for startups, where we can support from in terms of sort of finding the right product market fit, go-to-market strategy, up to financial investments as well. So we really try to help startups to come into the space and find the right way into this space, even especially if they come from outside the maritime industry. It's really important that they understand the intricacies and the unique characteristics of the industry, and we can certainly help with that.
Okay, thanks for sharing, Haymon. Moritz or Andres, do you have anything to add?
No, I think, I mean, Andres has given a very good explanation of how the DP system works. And thanks, Haymon, for highlighting it. Yes, it's, we're very much interested in making it more safe for our crew and technicians on board, and for increasing the efficiency, which also comes then with a reduction in carbon footprint, of course.
Okay, thanks for sharing. We have another question in the Q&A chat. It's how large is the current watch circle?
The radius is normally, I mean, depends on the weather, of course, but let's say when we are more or less 3 meters HS, we will be doing 1.5 meter radius.
Okay. I think that's all the questions we have today. Yeah, so maybe one last question to kind of wrap this all up. You did kind of share what you look for in a DPS system, what kind of the ideal characteristics. So maybe in 3 sentences, could quickly summarize what would make an ideal solution for PSO as well as Innoport. Maybe we could start off with Haymon.
Well, from our side, of course, looking from the investment arm, we of course look for a solution that is not only strategically valuable, that is also commercially viable. So, of course, on the technical parts, I will leave it to Moritz and Andres to talk about that, what the ideal solution will be. For us, of course, it will be, does it make sense as a package? Does it actually, can we actually build a company? So startup can build a company for that. So that's sort of one point. The second one, and that's maybe, should we actually look into sort of what is the ideal solution? Do we want to push startups already in a certain direction with a solution? I would say we have stated here a problem set, a challenge statement. And I would sort of urge startups always to think outside the box, because we have obviously all the expertise that we have in house, and we have the experiences that we have, but maybe there's something we've overlooked. So I would always urge startups to really think outside the box, come up with solutions that we might not have thought about. So that is maybe my closing remarks on that.
Yeah.
Yeah, I can just say the same as Haymon says. I can't tell you what the ideal solution is, because we have a problem. We want an idea of how we could solve this, but how you approach the solution, I do not want to tell you actually, because this should be encouraged to think out of the box, as Haymon said. I don't want to limit anyone participating in this challenge to certain points. We are probably a little bit blind on this, because we're so focused on our current operations, on the systems we have, that we are not capable of being creative enough on seeing something which might help us there. And that's why I can't tell you what the ideal solution is.
Andres, would you like to add? Okay.
Sorry?
Andres, would you like to add?
No, I don't have much to say. I mean, I think it's of great complexity, and it is. I mean, this issue is not only happening to us. So every let's say offshore equipment that will have to be deployed with high precision is having the same issues that we are having. So this is a common, let's say, common area on this industry where improvement is known that can be made. So yeah, I think here needs to be creativity, needs to be ways to measure mathematical models as well, and to orientate this in view of probability of occurrence, because waves are probability of occurrence as well. So it is not easy. It is not easy, and as well, all the certification that we have to go on top of this. So any person that is able to define or provide some clarity and some consistency on the measurements and on the way of providing those measurements, I think the business case will start to look very solid, because it's not only us, it's everybody that wants to do something precise at sea will see or will face all these issues. It's complex because sea is complex, but I think it's worth to have a depth look into it.
And also, I think, those regulatory things that come with it, we can definitely follow up on those questions if any come with during the Smartport challenge through the course of the next month.
Yeah. Okay, so thanks Haymon, Moritz, and just as well as Jessica for sharing context and your insights and all your experiences regarding this innovation opportunity. So for startups who are joining us here today, we encourage you to put forth a proposal, and if you get through the next round, you have the opportunity to work with BSO as well as Innoport to tap on all the expertise as well as industry knowledge. So I think we can go to the next slide. Yeah, so this is just to remind you that Smartport Challenge is closing on, applications are closing on the 8th of July. If you'd like to find out more about this innovation opportunity or other innovation opportunities, you can also head over to our PS Anyone website. Coming up, we also have our final Ask Me Anything roadshow for Smartport Challenge 2022, and this will be with OSM Maritime and ASMI on the 5th of July. Yeah, also do continue to follow us on our LinkedIn page and also subscribe to our newsletter if you haven't to get the latest updates. Once again, thank you everyone for joining us here today and hope you have a great afternoon ahead. Thank you. Bye everyone.
Thank you very much, Jolene. Thank you.
Thank you.
Goodbye.
Bye.
Bye.